Hi all, and today's video we will discuss about the sorted inserted linked list in Python. So that is our concept. That means we are given a key and we want to add it at the sorted position. So that is the condition. So for example, uh, yes, for example, if I giving an array, this is the linked list. You can see here. Okay, I'm deleting this one. Okay, yeah. This is the linked list. So we are call it as head. Okay. So I want to add a number 35. So this is my condition. I want to add a 35. The condition is there at this sorted position. So you can check here. The 35 is greater than 10. 20, 20, 35 is greater than 20. 35 is greater than 30. 35 is less than 40. So this is the point. That means this position we need to add this 35. Okay. The how this will be implemented, that is the case we need to check in this one. So there are three cases we need to discuss. Yeah, first case means there is no item, right? There is no item in the linked list. What it do? We can simply add this item as a node. We need create the node, then it is simply written. That is the first condition. And the second condition, this item is less than the if the linked list contain one node but the item is less than the given node, that means we need to pointing the new node as head. So that is the second condition. Third condition, as normal, we iterating through the linked list and find the position and insert it. So these are the three criteria we need to check in this case. So that I will explain. So you can already know in this step head equal to node of 10. So the node of 10, this one is calling, and node 10 created head, and node 20 as the second node, node 30 as the third node, node 40 as the fourth node. So the node 1 is created, then the function is sorted insert. We are passing the linked list here head and the value x. So that is passing. First, we are creating a node temp equal to node of, that means for example 35. So a node temp node is created here, temp equal to node x, and then if head equal to none, that means there is no item. What will do? We can simply return the temp. Otherwise, else if x less than head dot key, temp dot next equal to head, return temp we can return. Okay, if the key is in the first position. Else, what we do, we are normally doing the iteration process, right? Current equal to head. We are assigning to current equal to head position, while current dot next not equal to none, and current dot next dot key less than x. So that is the condition. That key always less than x, and this is in the iteration loop. Then only we can the current dot next means key is less than that value. Then we can check here. For example, here we are checking 10 is less than 35, 20 is less than 35, 30 is less than 35. So this is the criteria. And the next we do, if that criteria, that means in the 40 range, it will be less. So that time, temp dot next equal to current dot next. So here, this is the temp function and temp dot next. That means the link will be this one. That means this is the current. So we are assigning temp dot next equal to this one and current dot next equal to temp and current dot. So that time this link will be creating here. So temp dot next equal to current dot next and temp current dot next equal to temp and return the head. So this we can simply write here. So 10, 20, 30, 40, but in the 35 is added here. So this is the list of the sorted item and the time complexity. So here definitely you want to check. I will tell you this is the first criteria. Okay, when you check first condition on first check and the second check if the node will be the head node. If a linked list contain only one item and it will be the head node, that means the less key. So this is the second case and this will be the third case. We are iterating through the loop and find the lesser position. Find the position and insert it. So these are the three things definitely you want to check. And if we are talking about the time complexity, yes, time complexity means bigger of n. That means we need to iterate. That means the n times, right? So bigger of n is the time complexity. Complexity is bigger of n. And space complexity is bigger of 1. There is no space is required, right? Only iteration is going there. So that is the reason. I think hope you all clear. If you have any doubt, just comment below. Okay.